And so, OpenCV, are you guys familiar with it? I know he's familiar with it. OpenCV is Open Computer Vision. It's an open library that helps you do all kinds of image processing, computer vision, and machine learning. This we'll learn next week. It doesn't belong to here, PCL. So it does a lot of general image processing functions, changing color to gray, or color black to white, or resizing, or whatnot, segmenting by color, by movement, doing transformations, like the same transformations from kinematics, but using camera models. Things from machine learning, especially for face recognition, identifying features and images, tracking motion, matrices, camera calibration, and whatnot. Okay, so OpenCV is the golden standard for image processing. It's open source, so it's always growing and changing. Okay, this library is maintained by a robotics group. Yeah. Okay, so the things that we're going to learn is first how to connect to a webcam, or I didn't bring the Connect today, so we won't look at that, but how to connect a webcam to ROS. You know, show like in your own laptop, you have a webcam, right? That could be any camera or a webcam. Just visualize it in ROS, and then how to use OpenCV in ROS through something called the CV bridge. And as much as we have time, there's all these examples in code from the book ROS by Example 1, detecting faces, tracking key points, following objects of a particular color, tracking a person's skeleton. We may try to do that maybe next week. So image resolution is very important, guys. You know, images can be taken at different resolutions, 160 by 120, 320 by 240, 640 by 480, like that. Which one do you think we use most in robotics? Right. 2 or 3, depending on your computer power. Of course, computers become more and more powerful, but some of your computers, if you use 3, will be very slow. We'll see in a second. When you have higher resolution, of course you get better detail, but you need more computer processing. Now let me ask you, if you go from 1 to 2, how many times more computer processing do you need? Very good, 4 times, because it's square, right? You double the size of the rows, double the size of the columns, so you need 4. If you go from 1 to 3, you need 16 times more, and if you go from 1 to 4, you need 64 times more processing, right? So let's say if your computer is struggling to run at 320 by 240, 20 frames per second, and then you change the resolution, it will struggle at 5 frames per second. So it'll look very choppy, like it won't look like smooth video. Okay, so just a little note. Okay, webcam. Down here, you want to go to your workspace and say git clone, github.com, Bosch ROS package, USB cam. Okay, you download that, and then you do catkin make. And then let me show you one thing though. ROS CD USB cam. Okay. Here we're going to go into the launch folder. Okay, and you have this USB cam launch. This is very important. I think it hasn't been fixed. When you originally opened that launch folder, that launch file, this will have a different pixel format. I forget what it is, but it's something else. You need to manually change it or make sure it's YUYV. Yeah, some kind of intensity pixel format. Yeah, if you don't change that, it won't work. Okay? Okay, let's go back to this. So, really quick, Image view is the package that we use in ROS to do video streaming, right? I gave you an example of that. And there's something called the image pipeline or the image stack. We don't use the word stack anymore, but also it's ROS based. It's in ROS, but it's OpenCV based. Calibration, monocular images, stereo images, depth images, and other kinds of visualizations. So different nodes in image view package can help you see color, depth, or stereo. They're not the same. So color, of course, is just normal. Depth will be a gray image, white, gray, black. And then things that are very far are white, things that are very close are black. Stereo images is taking both images and doing some appropriate publication of the images. Yeah, so basically ROS run image view, and then here you have your remapping of the topic. Sometimes if you're using wireless internet, you might want to compress the image. Make it small, send it, or transport it, and then display it. Because, again, images can take a lot of bandwidth, a lot of memory, depending on the resolution, and especially if you're streaming them 30 times per second, right? That's a lot of information. If you want to use 2 cameras, yeah, you don't have that here in your webcam or in the Connect. Sometimes you have 2 cameras set up. You have to do something like this: ROS run image view, then stereo view. And then you say stereo for the remapping. And this would be actually kind of like a namespace, something that you use for both cameras. And then here is, let me see, so here, for example, to view stereo image pairs on topics, like this, image rectified color. Oh, and this is whatever you want to look at. So for us, we've been looking at image raw, right? So this would say stereo, and then image equals image raw, something like that. Does that make sense? No. This is a name that you choose for your common namespace. Like up here, we have the example. If I wanted to display like this, my stereo cam left image rect color, then this name would have to go here. If you just want this to be stereo, then you take the word stereo and you put it here. And the same. And then for us, we've been using image raw, right? Actually, there's a few different ways to publish topics of images. This is a rectified color image. It means after it's being calibrated, so you can put that in here. Okay. Actually, we didn't try it, but you can go back to your gazebo simulation with the multicam. Let me see if I have that here. This is still running, right? So right now we say ROS topic list. We have that stereo camera left image raw, right? So you can say ROS run image view stereo cameras, stereo equals stereo camera, and then image equals image raw. Yeah, because we have like image raw here. And so here, right, left, and disparity are the three things that show up, but maybe I made a mistake. I don't know if this not sure what the error is here, but basically this is how you would run it. Yeah, maybe it's the Gazebo plugin, I'm not sure. Exit. Let me see. I'm still running. I was still running the calibration node. I don't know if that may be affecting the image view node. Let's try again. No, it seems it has a problem. I'm not sure if this has to do with the plugin or not. Okay. Anyways, let's keep going. So this is connect. I'm gonna skip that. So if you want to start the driver for your webcam, you can do it like this. So you can say ROS launch, RBX1 Vision, USB cam .launch, and this video device actually it's set in the launch file, but if you want to run it, you can do that. And my webcam has a little light turns on. So right now, ROS can see the image from my camera. How do we display it? Come on, my friend. How do we display it? Display the image, the video. Display the video. You guys need to improve here. Look, it's everything we've been talking about. ROS topic list. Yeah? Here's a ROS topic list, right? Here's a topic that is being published by the node that we're running. So how do I visualize it? What do I do with this topic, guys? Eli, what do I do with this topic? What do I do? How do I visualize it? How do I look at it? Use what? ROS run what? ROS run what? You need to say image view. Yeah? That's what we've been using many, many times. Image view, image view, image view. Yeah? Image view, and then the topic. I've mentioned this many, many times today. Yeah? Image view. Now, there's some problem with this driver, and recently with the older version of Linux or older version of something, it looked very good. Maybe there's some parameters that we can change. This is very bad, of course. I don't know if in your computers it looks better. Yeah, but basically it's capturing the video, it's just not doing a very good job. Okay, let me see another thing here. ROS launch UVC cam. This is a different thing that I have. ROS launch RBX1 Vision. No. I think maybe I took this one off because there was another driver, but it's not maintained. ROS run UVC cam. No, it doesn't work. Okay. So basically, we have this USB cam. And we can say ROS view, image view. Image equals this guy. Okay, there it is. Not very good, but there it is. Actually, that's not the main point, but let's keep going. So let's see, where was I? Image view, webcam, this one, okay. So we're here and we're looking at the webcam and we can visualize it like that. You can try UVC cam, but I think it's not working anymore. And now let's go to the CV bridge and see what CV bridge is doing. So ROS has one way of representing images, right? What is the message that we use for images? Sensor messages image, right? Sensor messages image. Internally, when you go into the C++ code or the Python code, we use ROS messages to publish and to subscribe to images, right? And so we use sensor messages image. I'm not sure why it's doing that. So we use the ROS image message. OpenCV uses something totally different to represent images. It's not the same thing. But what we want to do is, for example, we get an image from the webcam or from the Kinect into ROS. But we want to do OpenCV, we want to use OpenCV methods on those images. So we need to convert them from this type to this type. OpenCV Bridge does that. It changes the type. Yeah? It's a little bit like you say ni hao to me, and I change it to English and I say hello. Right? I convert one to the other. And then you do the manipulations here, change colors, find the face, whatever it is. Then the output might be a black and white image or a square around the face or whatever that is. You convert it back to a ROS image, and then you display it. Yeah? So that's what OpenCV Bridge is. And let's see, so we're gonna run, we have the USB cam launch running here, and then we have a node called CV Bridge Demo.py. And the way we need to run it is a little bit like this. RBX1 Vision, CV Bridge Demo.py. We need to do some remapping. Right now, when we run USB cam, this one, the topic is camera, RGB, I think image raw, I think this is, yeah. But this Python code needs it to be input RGB image. So we do the remapping of this one. But we need to do two remappings, not just one. There's another one called camera depth registered image raw. And we need to change it to input depth registered image. This is wrong here. Okay, so it's a lot to write. And when we do that, we'll get an image like this. Let's take a look, okay? And then we'll go through the code, which is the important part. So right now my webcam is running, although not very good. And sorry, let's go back here. So we can say ROS run RBX1 Vision, CV Bridge Demo, input RGB image, remapping of camera RGB image raw, space, input depth registered image, with camera depth registered image. Actually, this depth thing doesn't matter because I'm using a webcam, not a Kinect, so we're not going to get any depth from this. So depth is nothing, but this is kind of getting edges. This does not look great because the original image, is very white. Yeah, so you can't. Oh, maybe this is very sensitive to the light. Look at my shirt. Yeah, it's picking up. That just happened with light. Maybe the sensitivity to light is very big. But you should see even more. You can see a lot on my hair. Yeah? This is edge detection. So it's looking at big contrasts, in light to compute some edges. But here light is definitely making a big difference. Yeah? It's very sensitive to light. Okay, let's look at that code. ROS said RBX1 vision CV bridge demo .py. So a lot of the code here in RBX1 says something like this. At the very, very bottom, there's the condition if name equals main. That's what, in Python you do that if you're going to be an executable, right? So if main exists, this will be true, and then you go down here. Now main here is just the name of a function, and you're passing the arguments from the command line. So it calls main, and then you come here main with arguments, and all you're doing here is 2 lines. CV bridge demo, this is a class that we're creating here. So it's going to go into the constructor of the class, and then it's going to call spin on this. So let's see what the class looks like. We come up here, and here we have the constructor. So we give a node name, we initialize the node, we create a function called onShutdown, and sorry, this is a function that exists from ROS.py, and we can pass another function that we call cleanup into this that does whatever we want it to do. Basically here we're just stop the camera driver and close the window. Okay, what's the first thing that we need to do? We need to create a display window. Yeah, we need to open a window, and in that window we're going to show the video. Okay, for the RGB image. So we're in the constructor, and we're going to create an internal member called CV window name. Okay, and that name is equal to our node name, CV bridge demo. So now we have a name for the window. So this now is a function, part of CV. By the way, you need to say here at the top, import CV2, and then you need to say import CV2.cv as CV. This is just a shortcut for OpenCV2. We're using the second version in Python. There's also OpenCV3 now. Yeah, but we're not going to be using that. So we say CV named window. The first parameter is this one up here. It's the name. The second one is saying I'm going to create a regular CV window. Tell me your name again. Shili. Shili, how many types of windows do we have in OpenCV? How many do you use? That's fine. Okay, so this is just basically a normal window. It creates a normal window. Then, if you want to move it, and meaning where does it show up in the image, you can say I want it to show up at a particular point. Remember 0, 0 is the top left corner. So 25 along the X, 75 along the Y. That depends on your screen resolution, what that means. We're going to open a second window for depth. Okay, so you do that basically the same thing. Sorry, down here, we call it depth image. Also a normal window. And you can see that it's a little bit further below. Then this line is very important. It creates the CV bridge. Where does this come from? From right here, right? This is a module that is standard with ROS, CV bridge. So from CV bridge, import capital CV bridge. Okay? So then, with using the parentheses, we can create the object self.bridge. Okay, so that's all CV stuff, right? We created 2 windows, and we created an object for OpenCV, CV bridge. Now we go back to ROS, and we need to get the image from the webcam. So we create a subscriber, and we subscribe to this topic with this type. This type is what? It comes from up here, from sensor messages.message import image. Okay? That's the type for image in Python. And then we need the callback, self image callback. That callback is defined down here. We'll take a look at it in a second. So basically, anytime we get an image, we are going to call this callback. All right? And then we create a second subscriber for the depth image. Okay? When you use a Kinect sensor, you can see the depth. Or if you use cameras and do some sophisticated manipulation, you can get depth as well. So let's look at image callback, which is the image callback, right? Here we need to pass ROS image. And let's see, where's ROS image? What's this ROS image? I forget. Oh. Let me see. One second. Let's take a look inside. First line. What we want to do is use CV Bridge to convert the ROS image to OpenCV format, right? ROS to OpenCV. So we have this object bridge, right? That we created up here. Self-bridge, self.bridge. And then we use the function image message to CV2. Yeah. This is the ROS image that was obtained. Oh, that's what was confusing me. And this one from the callback. Yeah, okay, so this is just the ROS image that you get from there. And you say, I want to convert it, I want to use this image to convert, and I want to use this encoding type, RGB 8 bits. If there's any error, you can put that in a try except block with a CV bridge error, like something went wrong with that. But basically, this is what you're running. So then you have this variable frame, which is an OpenCV image. Tony, take notes. Take notes. Now, the next thing that we're going to do is convert the image into a NumPy array. Into a NumPy array, because many OpenCV functions expect the image to be a NumPy array. A NumPy array is like a matrix, okay? So basically, if you have a 10 by 10 image with RGB, it's a 10 by 10 by 3 matrix, okay? So you convert it into a NumPy array, and to do that, you say, here's my variable, and you need to tell a type for the NumPy array, NumPy uint8, because we have an 8-bit type. Oh, these are unsigned integers, 8 bits long. This is fine for representing the values at every point of the image. So that's called frame as well. Okay, now that gets interesting. We have this method called process image. and you put in the NumPy array, and it gives you out the modified image. Yeah, display image. So this function here is where we're going to use OpenCV functions to change stuff. This is a little bit further down. I'll show it to you in a second. And here, if you want to display the image, you can say CV2 image show. Here you take the name of the node and the display image that you created here. And this will then put the image on the window that you created earlier. Okay? This is to kill the window, so if you press Q, it'll say ROS.Pi signal shutdown and make it disappear. Let's look at process image, which is up here. Okay, so process image takes that NumPy array. Okay, and what we want to do, as you saw, is find the edges on the video, right? So you take that image and you say, I want to use the function CVT color. The first thing we're going to do is change from color to gray image. Some algorithms in open processing, and that's out of the scope of today's class, need gray images instead of color images. Sometimes it makes the computation faster because a gray image only needs one layer. Color images need 3 layers. Yeah. So you say use CVT color, take frame, and convert from RGB to gray, to a gray image. So now you have your gray image over here. Then the next thing you want to do is to blur it. Why do we want to blur it? Because if you don't blur it, you have too much contrast, too many sharp edges. So actually the image would look like white lines everywhere. So you blur it, and that means you only keep the strongest edges, the strongest contrasts. So you say, take the gray image, and this 7x7, what's the name of this thing? It's the size of a marker. The size of a marker, and basically it goes through the window and it blurs the image according to that size. There's a special name, but I forget right now, for that marker. So you can, it's a little bit like if you used Illustrator. Sometimes you click on brush, and the brush can have different sizes. So you can blur very big parts of the window at the same time, or small parts of the window at the same time. Yeah, it's different ways of blurring. So then you have a blurred gray image, and then finally you use the algorithm to create the edges. There's 2 kinds of algorithms to do that. One of them is called the Canny edge algorithm. So CV2.canny gray, and then this is some other parameters of size. You can find them in OpenCV, and so then you get this edges NumPy array that you return. And so when you return that, where were we? In the callback. Yeah, it goes here into display image, right? And then you do this, and then show it. And at the bottom we have this spin, so it's constantly getting new video, and you're constantly getting calling the callback again. And you're constantly applying the processing to the new frame. So here comes an image, convert it into an edge, new frame, convert it into an edge, new frame, convert it into an edge, and publish. Tony looks confused. You get an image, change it, new image, change it, new image, change it, new image, change it. It's video. It changes all the time. You get 30 frames per second. So you publish 30 new images per second. Okay? Now, so for your homework, you go through this presentation. There's many different examples. You go into the Python script and you study, you run it, maybe you debug it with settrace. Yeah? Debug the Python code. All of you should know how to debug Python code by now. If you don't, get some help. Yeah? And you go through all of this. So basically you do this, right? The next one, so this is an explanation of the code. The next one is this code that you create a region of interest, ROI. The region of interest, basically you have an image, right? You use your mouse to click on an edge, drag, and then let go on another edge. So here, wow, this looks terrible, sorry. What's going on? All of this looks rough. Some bad connection somewhere. You cannot really see it, but basically the region of interest, I click from here to here. Basically I'm covering my face, and this has a starting XY point and an ending XY point. So for example, if you want to do facial recognition, you might, not necessarily, but you might tell the algorithm, just look from here to here. Not look at the whole image, just look in the region of interest. Or if you want to do color segmentation, you say, don't look at the whole person, just look at my hand. Segment this here. I'll show you maybe quickly how to do that. So I'll skip face detection. Maybe I'll just go to color. This one right here. So it's very easy. You have your video running and you say ROS launch RBX1 vision cam shift launch. Let's see if we can see it with the distorted video. So you say ROS launch RBX1 vision cam shift launch. So you get a new set of windows opening up. And let me see. I need to choose in the region of interest. Let me make this, sorry. Here you can almost not see my face, right? Let me see if I put this book here. It's still not very clear. Okay, let me put something around my hair, which is kind of black. Oh. Had some, what's going on? Doesn't seem to let me catch the region of interest. Let me start from the beginning and then there's some things that are still running. Okay, let me try again. Am I missing? Maybe I'm doing something wrong here. Yeah, but I'm doing something else wrong. I should just be able to see my video here. and I don't see anything. We were seeing that before. This always works perfect, and I've run it hundreds of times. I'm not sure what's going on today. Oh, you know what? I think I know what's happening. I think this is expecting. Let me show you. I think the topic is wrong, because I think this code was originally created with UVC cam. And okay, let me check something real quick. RBX one vision, and then cam shift .py, and then subscribe. Where's the subscription? Subscription image callback. No, this is not working. Where is my subscription? There's no subscription here. This remapping from to. I think this is the problem, guys. This particular driver does camera RGB image color, but the algorithm expects camera RGB image raw. Let's see if this fixes it. So let's run that again. No. No. That sounds like a nice thing. It's maybe it's something about the topics, but I can't run it. Maybe you guys try it at home. Okay. Yeah. That's the homework. Okay. Just go through the code, get it to work. It's very interesting. Basically, let me tell you how it is. You run 5 algorithms. Most of them are about face tracking, but the first one, you do a complicated machine learning algorithm that's very slow and not very good. Then you try a very simple algorithm that tracks key points. But those key points disappear over time. It's not very good. So the next thing you do is you add something called optical flow. It tries to perceive the movement of the human and updates the key points based on the movement, and works better, but there's still noise over time. So then you basically create new points after some time, dynamically adding new points over time, and so you can kind of keep track better and better over a long time. And then you say, how do I combine all of these and make it work best? You find the face at the beginning and keep the region of interest, and then add the key points inside the face. So you do the expensive routine only one time, not all the time, and then use a cheap or fast routine afterwards. And you can keep track of the face very, very well at the end. So if you get it to run, you'll just be moving your face like this, and you'll see that the algorithm can follow your face very well. Then you can try color, and color is very interesting. You could maybe use your hand or your face, and basically, if you move your hand like this, you can compute the error between the position of your hand and the middle of the screen. So if you move to the right, you create some error there. If you move up and down, you create some error there. Then you can use that error with a PID controller to tell a robot to move. Yeah, it could be a mobile robot, it could be an arm, it could be anything. So when you do this, you create some information, some error, multiply it by a gain, send it to an arm to move up and down, or move a mobile car to rotate, or to move forward and backwards. Yeah, so it's kind of cool. You just move like this, and then you can move the robot. And then if you use the Kinect and you do skeleton tracking, you can do 3D tracking of your hand or your arm, and then you can use those signals, send them to a robot, and tell the robot to move. Yeah, so it's like that. Okay, guys.